Hello? Yo, can you guys hear me? Alright, so I have acquired the 2021 paper, and in addition to the 2021 paper, I've also acquired the quote unquote 2021 answer booklet. Yes, the 2021 answer booklet. So yeah, I guess we shall make a start. It is currently 7:37. I will try and finish before the 3 hours are up. Yep. Uh, okay. So the first thing I realized is that the 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 cropping on the PDF reader is looking a bit saucy. So hang on. All right, there we go. So you see question 1A now. Yep. Question 1A. Alright. I don't have the speedrun timer this year, unfortunately, because I don't think a speedrun timer really works. I don't think a speedrun timer really works if wait, hold up. This is so sussy. I hate OBS, bro. I hate this shit. Alright. Alright, there we go. So the first question, consider the function f of x equals x squared minus x minus 2 over thingamajig. Use a number line to show where f of x equals 0. I mean, I don't need a number line, bro. I got calculator. Watch this, right? So x squared minus x minus 2, x squared minus 2x minus 3, right? So you just graph it. Yep. And then, okay. Alright, so what you probably want to do, 1a, f of x equals x squared minus x minus 2 on x squared minus 2x minus 3. Yep. Hang on. This is a bit saucy. Okay. Equals, you probably want to factor the top, right? You go x minus 2, x plus 1. Then on the bottom, it's x minus 3, x plus 1. Appears to be legitimate. Alright. So, like basically, when x isn't -1, if x equals x minus 2 on x minus 3, and if x greater than 0, if x minus 2 and x minus 3 greater than 0 implies x greater than 3, if x less than 0, if one of them's bigger than 0 and one of them's less than 0, so you just write like this, and that occurs when 2 is x is between 2 and 3. If x also bigger than 0, if x minus 2, x minus 3 are both less than 0, that occurs when x less than 2, and x equals -1 is sussy. Alright, so now we draw the number line. I don't have a ruler, by the way. And then just basically just copy what you see on the graph. That's basically it. Alright, second question. Find all real solutions of the following equation. X to the power of x root x. What is it? X to the power x root x equals x to 2x. Alright, so this is a bit of a troll problem, right? Because like if x equals 0, x equals 0 is a bit sussy as well. Sussy. If x equals 1, then it doesn't really matter, right? Because 1 to the anything. Come on. Then the sides are undefined. If x equals 1, then 1 to the 1 equals 1 squared. So this is a solution. And then otherwise, because x to the y is strictly monotonic. Otherwise, when x greater than 0 in y increasing, then x to the a equals x to the b implies a equals b. Hence, x root x equals 2x. And you can basically like cancel the, well, not really. So you go x root x minus 2 equals 0, and x equals 0 or root x equals 2. So x equals 0 or x equals 4, but both sides are undefined. At x equals 0, hence x equals 4. And I'm not sure what to do about the negative x case, because that's a bit sussy. Like if you draw, what is it, like negative 1 to the power of x, right? That's a bit unfortunate. That was not negative 1 there. Like you get this, right? Because it alternates between being positive and negative depending on wait, what? Negative 1 to the, oh right, because okay. Oh wait, but then if x is negative, wait, so do they ask you to solve it all? Oh, real solutions. Alright. So if x less than 0, then root x is not real. But then like, how do you prove that negative number to the power of a complex number isn't real, right? Because like technically, like what if x to the power of 2x was like also a complex number, right? Like cause if x is negative, then like you could x to 2x could possibly be a complex number, right? I feel like I'm overthinking this, but I was just gonna say if x less than 0, then x is not real, so no solutions here. Alright, there we go. Let's go. Question 1c. Find the equation of a vertical line which halves the area enclosed by those two parabolas. Okay. Y equals 2x squared minus x minus 1. Y equals negative 2x squared minus x plus 1. Alright, so just draw it on the calculator, right? 2x squared minus x minus 1. Minus 2x squared minus x plus 1. Alright, it draws. Oh, so this is the area that's halved in between them. So like, alright, so you go like y1 minus y2. That gives you the difference. So you see, like, this is 0 at like around about 0.6, 0.7-ish. Probably like given it's so close to 0.7, I just say it's 1 over root 2, but obviously you have to prove that later. Actually looks like 0 is the vertex of this parabola, but obviously prove that later. So yeah, so let's say y1 equals this, y2 equals this. So y1 is like this. Y2 is like this, right? Y1, Y2. I'm just drawing off what I see on the calculator, right? So how does this work? The distance between them is y1 minus y2, which is 4x squared minus 2. I mean, funny how that works. And this is a parabola, right? This is a parabola. This is a quadratic. And this is a quadratic. Note that the vertex of this quadratic, right? So like and then this is the area. This quadratic lies on the line, the vertical line. Well, this is what they're asking, right? Equation of a vertical line which halves the area enclosed. Yeah, okay. On the vertical line, x equals 0, right? Hence, the vertical line x equals 0 halves the area by symmetry. Alright, let's go. Question 1D. Bro, it's integral. Okay. 1D. What are we doing here? Integrating from 0 to 2, x on root x plus 1 dx. Alright. So, the way you want to do this is probably alright, let's try IVP, right? Let's try IVP. 2, 0, x plus 1, negative 1 on 2, right? So you got x plus 1, negative 1 on 2, right? And then this becomes 1. So you differentiate this, but you integrate this, right? So this becomes x plus 1, 1 on 2, 2. And you integrate this one again, so you get x plus 1, 3 on 2, 4 on 3. And you multiply like this, and then you go plus. Multiply like this, and you go minus. I think that's how it works. Plus, minus. Seems about right. Okay. Then you go, which is just 2x. X plus 1, 1 on 2, minus 4 on 3, x plus 1, 3 on 2, evaluated between 2 and 0. Alright, and then the first term has a x in it, so it's like 2 times square root of 5 minus 4 on 3, 2 plus 1. Wait, no, not square root of 5, it's square root of 3. Yeah, square root of 3. Square root of 3, 3 on 2, minus, you know how to do this, right? 2 times 0, 0 plus 1, 1 on 2, minus 4 on 3, 0 plus 1, 3 on 2, plug and chug, what do you get? 2 times root 3, minus 4 on 3, times 2 plus 1 root 3 on 2, minus 2, oh this is 0, so don't bother, 4 on 3, 1, times probably, 4 and 3. Alright. And this is why graphics calculators are OP, right? Watch this, watch this. You can literally check your answer, right? So you go math, then you go option, calc, integral. Integral of x on root x plus 1 from 0 to 2. And you get 4 and 3, so you know you did it right. Alright. Well, you don't know you did it right. Maybe you did it wrong, but you still got the right answer. But at least you got the right answer, right? Okay. The graph below shows the curve sin x minus cos x on the domain. Oh, the absolute value. Yes, the absolute value. Sin x minus cos x on the domain 0x to 2 pi. Ah, it's not an integral problem, bro. What's this? Alright, 1e. So I guess like the first order of business is find out like where it actually intersects the y-axis, right? I mean the x-axis. So you wanna like integrate. Well, where's sin x equals cos x, right? That's what you wanna know. Sin x equals cos x. Sin x equals cos x. And then if you like actually do this, you get tan x equals 1. Right? And then you get like this kind of graph for tan x. I can't draw. That's like hits 1 at like 45, and there's like 90 the asymptote, then 180, and it hits 1 again at like 235. Oh, everything's in radians. Okay. It's pi on 4, I guess. Pi on 2. Pi. 5 pi on 4, I think. Yeah, so x equals pi on 4 or 5 pi on 4 if x 0 less than x less than 2 pi. Alright. So what do you do with this information? Basically, like, you want to be integrating, because, like, okay, look at the graph, right? Look at the graph. So you want to go, like, sin x minus cos x, right? That's the graph. So here it's negative, right? So you want to integrate. So you want to integrate, like, okay, so integral of sin x minus cos x dx between 0 and 2 pi. The integral of that absolute value is the integral of the negative sin x minus cos x dx from 0 to pi on 4, right? And then you see up here it's positive, so you actually want to be integrating it. Plus the integral from 5 pi on 4 to pi on 4. Note cos x greater than sin x if and only if fuck. Okay, so you bring this down. Not so much. Alright. If and only if x, for fuck's sake. Okay. If and only if x less than pi on 4 or x is greater than 5 pi on 4 when 0 less than x less than 2 pi can be seen by by drawing both graphs. Hence, by definition of absolute value, right? Because like sine looks like that, and then cos looks like that. So okay, so by definition of absolute value, it's like this. And then for the last part, 2 pi to from 5 pi on 4 to 2 pi, you just want to integrate the negative as well. Right, and then what you end up with is what you end up with, what do you end up with? You end up with, okay, so the integral of negative sine x is cos x, and the integral of positive cos x is sine x. That's from pi on 4 to 0. And the integral of sine x is negative cos x. The integral of negative cos x is negative sine x. That is from 5 pi on 4 to pi on 4 probably. And the integral of this is cos x plus sine x. 2 pi, 5 pi on 4. Actually, wait, no, this is so dumb. Alright, no, watch this. Alright. We can rewrite. I'll just finish this. Right? Because I've like dug myself a hole, so I might as well just like, sleep in it or whatever the saying is. I don't know. Cos of pi on 4 plus sine of pi on 4 minus 1 plus negative cos of 5 pi on 4 plus sine of 5 pi on 4 minus cos of pi on 4 minus sine of pi on 4, and add sine 2 pi plus cos 2 pi minus sine 5 pi on 4 minus cos 5 pi on 4. You get 4 root 2. Alright, 4 root 2 is the answer. Probably. Let's check. Does this have an absolute values thing? Yes, it does. By the way, I am using the upgraded OS on this calculator, so you can see like it has the natural display and everything. This is, I believe this is the OS for the 9860, but you can get it on the 9750, which is the one I've got here, and it's a completely safe procedure. So yeah, this video is on YouTube if you want. But back to the topic. We want to integrate sine x minus cos x from 0 to 2 pi, and that's 4 root 2 as well. Yeah. Alright, so the big brain solution, right? The big brain solution is we simply write sine x minus cos x is equal to root 2 times sine of x plus pi on 4. Or minus, I don't know, let me check. Root 2 times sine of x plus pi on 4. Pi on 4. No, yeah, it's minus. Yeah, x minus sine of pi on 4, right? And then like, no, this is correct. And this is wrong. Hang on. Let's get out of here. Alright. This is actually root 2 times sine of x minus pi on 4. If you don't believe me, you can check. You can like use sine a plus b equals whatever to check. Yeah, so basically, and then the integral of 0 to 2 pi of the absolute value of y is just the integral from 0 to 2 pi of the absolute value of root sine x minus pi on 4. And this is 1 period, so it's equal to the integral 2 times the integral from pi to 0 of root 2 sine x, which everyone knows is 2, right? 2 root 2 is 4 root 2. Alright, so because 0 to 2 pi is a full period. Alright, there we go. I think that's question 1 done, so let's go on to question 2, I believe. Bro, what is this shit? What? Log? What? Bruh. Bro, NZQA done me dirty, bro. What's this shit? If log of... Oh, wait, no, okay, it's not too bad, it's not too bad. Alright. So log base A on B equals 5, right? a on b to the 5 equals b. A to the 5 equals b to the 6. Right? That's basically what it means. Right? I don't know why you can't put like a bracket around the fraction at the bottom, but that's I don't know, it's not here or there. Okay, so alright, so you just try like a random case, right? Where like what if a equals b equals 1? I think it doesn't quite work. A to the 5 equals b to the 6, right? So like, you try a equals 2 to the 6 and b equals 2 to the 5, right? So log you know, our log 32 of over log 0.5 is negative 5. That is an issue. What's wrong with this? A to the 5 equals b to the 6. Oh, it's a on b, right. So log 2, right? Log 32 on log 2 is 5, right? So and then you go log of third root of 32 times fourth root of 64 on log 2. Wait, no, that's wrong because the log is inside for some reason. Okay, divided by log 2. It's 19 on 6. So you know your answer should be 19 on 6 because like the way the question is phrased, right? The way the question is phrased is a short answer question. And then yeah, the way the question is phrased, it implies there's only one correct answer. So the answer that you get should be 19 on 6. 19 on 6, right? So you go log. Oh, so basically what you want to do, right, is you want to go a6 on b6 equals a to negative 1, I believe. That means log a on b. No, there's something wrong with this. Oh, yeah. So, hence, a on b to the negative 6 equals a. So, this is actually negative 6. Right, so now what you want to do is you want to come over. Wait, doesn't seem right. Nah, should be right. Okay. So, log let c equals a over b. Log c 3 root b, because I just can't be bothered writing it out. Times that equals a third log cb plus a quarter log ca by log rules, which is a third. Well, log cb is 5, is given, plus a quarter and negative 6. That seems wrong. That does not seem like 19 on 6 to me, but oh, right, cause this is actually wrong. This should be, wait, what? Oh, right, yeah, this is 1. So yeah, cause like you multiply it and then you get, yeah, you add 1. I made a mistake there. Okay. And then what's 5 on 3 plus 6 on 4? Oh, that's 19 on 6. There we go. 19 on 6. From all the possible pairs of positive rational numbers that add up to 11, find the pair that maximizes the product square of the first number and the cube of the second number. Bro, this is like some AMGM shit, bro. Alright, let's go. Actually, no, I'll solve it with Lagrange multipliers. Nah, I can't be bothered. Okay. What is this, bro? Find the pair that maximizes the product of the square of the first number and the cube of the second number. So you get a plus b equals 11, right? A, b, and q. Right? And then you f of x equals the product of the square of the first number and the cube of the third number. The cube of the second number. This is sussy as, bro. This is sussy as. And it's rational. Why do they get? Why is it? Oh, Q plus, right? Positive rational, makes sense. Also, maybe you can't do AMGM on this, cause no, you should be able to. Yeah. Well, I don't know. Let's see. Let's see. Okay, so we go here. We go x squared 11 minus x to the 3. View window. Wait, zoom. No. What are you doing? Zoom auto. Yep. That's very nice. But I wanna zoom. I wanna zoom in on the y-axis because I can't see jack shit right now. Zoom in. Yep. Alright, so it maximizes the product, right? That means it's like somewhere around here. Like y equals 4.33, 4.48-ish. Okay. Well, we know that b is equal to 11 minus a, right? So f of a equals a squared 11 minus a cubed. Alright, we're getting somewhere. This is equal to in turn. And then the derivative of this, note, 0 less than a less than 11. Okay. Derivative of this, you apply product, well, you get 2a 11 minus a cubed plus a squared times negative 3 times 11 minus a squared, which is, very nicely, a times 11 minus a squared two times 11 minus a minus 3a equals 0, right? And then this is actually equal to, well, I mean, like, clearly, a is not equal to 0, right? And clearly a is not equal to 11, since a is not 0, a is not 11, then 22 minus 2a minus 3a equals 0. 5a equals 22. A equals 4.4. Alright, now we check this, right? We go G-solve, and then we go max. Y x equals 4.4. What am I talking about? Let's go. Alright. So, then like, I guess you just, what did they ask you to do? You just have to calculate it, right? Find the pair. Hence such a pair. Second derivative. Let's go. Second derivative of this thingamabob is, I really can't be bothered, you know, like, such a pain. Okay, well, you get the first one. 11 minus a squared times 22 minus 5a. You derive the second one, so you get 2a 11 minus a 22 minus 5a, and then you derive the third one, and then you get minus 5a 11 minus a squared. And if at double derivative at 4.4 is I don't remember. 4.4 is x 11 minus x squared times 22 minus 5x plus 2x 11 minus x 22 minus 5x minus 5x 11 minus x squared negative something with Bob negative 958.32 less than 0. Let's go. Hence such a pair is 4.4 6.6, something like that. Alright. So now it's C. Oh, this is like a dumb question, bro. 2C. We can write rewrite this as a sine pi x plus alpha plus b cos pi x plus alpha plus 1 equals c sine pi x plus beta plus 1. Easy. And this is because sine of, I don't know, whatever, a plus b is equal to sine a cos b plus sine b cos a, hint, and so to find where in this case a equals, I should use a different variable, sine of p plus q equals sine p cos q plus sine q cos p, where in this case p equals pi x plus alpha, q equals beta minus alpha, which implies that c cos q equals c cos q is equal to a, c sine q is equal to b, and hence we have like c equals a squared plus root a squared plus b squared, something like that. Q equals arctan a minus b. Right, so we can always write it like that. Hence, what is this? F of 2021 equals c sine pi times 2021 plus beta plus 1, which is c sine 2020 pi plus beta plus pi plus 1, which is negative c sine 2020 pi plus 1, because sine of x plus pi is equal to negative sine of x. It is a trig identity, I believe. We can check it. Equals sine, it is sine x. Yeah, you see the negatives of each other. Yep. But c sine 2020 pi plus 1, plus beta. Yeah, plus beta. I forgot that. Plus beta plus 1 plus beta plus 1 equals 1, 0, right? That's given in the question. So hence, c sine 2020 pi plus beta equals 9. F of 2021 equals negative 8. Alright. Given this. Bro, what? Oh, this is one of those dumb questions. Alright, no. Alright. It's all good. Okay. Okay, so you go, you implicit diff, right? Something like that. Then you take the natural log. Yeah, implicit diff. Ln fx, right, equals ln x squared plus 1 sine x Alright, so d on dx ln fx is equal to d on dx sine x ln x squared plus 1. Yep. Alright, and then we go f prime x on fx is equal to, right, d dx of this. So you so probably you yeet the first, keep the second, and then you yeet the second, you keep the first. Alright, this is the product rule. Okay, and then hence f prime of x equals fx times cos x ln x squared plus 1 plus sine x 2x on x squared plus 1. And they want us to evaluate it at pi on 2. Alright. F prime of pi on 2 is equal to f of pi on 2 cos, I probably should expand it out. Okay. What is it? Pi on 2 squared plus 1 to the power of sine pi on 2 times cos pi on 2. And we already know that's 0, so don't have to bother, but just write it out. Pi on 2 squared plus 1 plus sine pi on 2 pi on 2 on pi on 2 squared plus 1. Alright. And sine pi on 2 is just 1, so this is pi squared on 4 plus 1 times, and this is 0. And that becomes, and this is also 1, right? This is also 1. 1. That becomes that times 2 pi pi squared on 4 minus 1 plus 1. Alright, that's done. Oh, wait, I should probably just, yeah, cancel top and bottom, 2 pi. There we go. You can check with the calculator. Calc, d on dx. What are we doing? X squared plus 1 to power sine x. X at pi on 2. Where's 1 pi? Oh, right. Cause yeah, 2 times pi on 2. Yeah, this 1 pi. That's correct. So I should always check with the calculator, right? Cause I don't know, if you're going for like 40, the big dumb 40, then this can make you get like 39, and then you get the still big dumb, but like it's not 40, right? Okay, consider the function this majig. We're both in our real constants here. The function has a local minimum at the point. Yada yada yada. What are the values of m in it? Okay, so like the first thing you should notice is okay, so because 2e let g of x equals f of log x. I can't write that, can I? Technically, x squared plus 6mx plus n. Then g of log x equals f of x. G of log 2x, I should say. Right, and then since log 2 x is strictly increasing, over, this is over, wait, I can't technically do this, right? Because some weird shit goes on if you do. I'll just do it the dumb way. I can't be bothered. I have time. 100% not gonna screw me over later in the run, but okay. So we just sub it in, right? We just go if prime x. We just assume that it all works out happily. It does not work out because log 2x is weird to differentiate. Oh no, it's not that bad because it's just like ln x over ln 2 squared plus 6m ln x over ln 2 plus n, right? And then you just go, oh no, that's if. So, yeah, so if prime x, right? You just chain rule it. You got 2. You yeet the inside, right? So the inside becomes 1 over x ln 2. And then you just keep it, right? So you go ln x over ln 2. Oh, there's probably a better way to do it. Whatever, I don't care. Plus 6m 1 over x ln 2 plus n equals 0. Oh, no, there's no plus n, because you differentiate and it's a constant. Yeah. Okay. Yeah, so. How does this work now? Well, since ln x is defined, is real, then x not equal to 0, and since ln 2 is not equal to 0, we can cancel the x ln 2. So you got 2 ln x on ln 2 plus 6m equals 0. So you go ln x is equal to negative 3m ln 2. Wait, how does this work? Oh, no. No, it's the other way around. You go m is equal to, right, so you move it to the other side. 6m is equal to negative 2 log 2x. Right? And then, so you go m is equal to negative 1 on 3 log 2x, which is equal to negative 1 on 3 log 2 1 on 8. Does this have a log AB function, or do you just do it normally? Log AB, there we go. Log 2 1 on 8, which is just 1, yeah. I mean, you can figure that out like manually, but it's easier to just let the calculator do it. And if at since the local minimum, since the extremum is at x equals 1 on 8, f of 1 on 8 is equal to log 2x squared plus 6 log 2x plus n, which is supposedly equal to root 2, or that's what they tell us anyway. N equal negative 2 minus 6 log 2x minus log 2x squared. Well, x in this case is, x in this case is 1 on 8, so negative 2 minus 6 log 2 1 on 8 minus log 2 1 on 8 squared, which is equal to minus 6 log 2 1 on 8 minus log 2 1 on 8 squared, which is equal to 7 apparently. So, yeah, fair enough. I don't quite buy it, but how is it equal to 7? Like, oh well, whatever. So now we go do the usual, right? Log 2x squared, I believe, plus 6 log 2x plus 7. Yeah, no way. Oh, I should probably put the view window back to normal. Zoom out. Yeah, this one's looking a bit sussy. Maybe it's -6 log. No, I think I messed up somewhere. Okay. Where's this? I still don't get why it's like 6m log 2x. Because it's just like, what? I don't see where we messed up. Cause emis 1, yeah, that's what we got. Like even though I don't plot the +7, then the extreme still isn't correct. Like there's no extreme at 1 on 8. Wait, there might be. I don't know. Or maybe there is, yeah. Zoom in around this point. Zoom factor 5, y factor 1. Oh, there is! Yo, poggers. Zoom factor 4, right, zoom in. So yeah, 0.125. Yeah, okay, so it's correct then. Alright. That's question 2 done. Oh my god. Why? Why? Oh, yo, speedy memes. I'm a second year uni student. That's why I can't do the real exam. Yeah. They don't let uni students do it, unfortunately. It would be a bit unfair if they did let uni students do it, but yeah, that's why I didn't do the real exam, because I'm no longer a high school student. Yep. Alright, so question 3 now. The roots of this quadratic equation are sine theta and cos theta, right? Okay. This is probably like, okay, so you know that sine squared theta plus cos squared theta equals 1, yep. But then you also know that, by Vieta's formulae, sine theta plus cos theta equals negative b on a. Yep. Sine theta cos theta equals c on a. Yep. So at this point, I don't understand what the 1 minus cot theta is there for, but oh wait, is this just like, this is a bit saucy, because you want to prove that like, well, like most of this is assuming that like cot theta is not equal to 0 anyway, because theta would be well no it's not. What is it assuming then? Because like it only breaks when theta is equal to 1. But I don't see why. No, it only breaks when tan theta is equal to 1. But I don't see why that's not a valid solution. Like, I don't see why. Like, like, like the quadratic equation can have double roots, right? That's totally a thing it can do. That's saucy as, bro. That's saucy as. Um. what's wrong with this shit? What's wrong with my understanding of this question? Because like, Alright, let me look up the NZQA trig formulas. NZQA trig formulas. Will they actually give you an exam? Calculus, useful formulae. Trig, is there no trig? Oh, trigonometry. Tan squared theta plus 1 equals 6 squared theta. But I want tan squared theta minus 1 though. The sussy ass. Yeah, cause like the identity is tan squared theta plus 1. Tan squared theta plus 1 equals 6 squared theta, right? And what's the other one? Cot squared theta plus 1 equals CSC squared theta. But we're looking at 1 minus these trig functions here. So they don't actually know what they want you to do. Like, is that the only condition there? Cause like, all of that means that sine squared theta plus cot squared theta is 1. And by Vieira's you get sine theta plus cos theta equals negative b on a. Like, it's skull cal, it shouldn't be too hard to like connect the dots and figure out what's going on, right? Like, sine squared theta plus cos squared theta. Oh wait, and then they're asking about 1 minus cot theta. They're not even asking about like 1 minus cot squared theta. Alright, I'm just gonna expand it out. I reckon that always works with like skull calc problems. Just don't think about it too much, just expand it out. Sine theta 1 minus cos theta on sine theta plus cos theta 1 minus sine theta on cos theta equals sine squared theta on sine theta minus cos theta plus cos squared theta on cos theta minus sine theta. Now this is Oh wait, yeah, that's right. Okay. Yeah, sine theta minus cos theta. Yeah, there we go. Then you go sine squared theta minus cos squared theta. Because it's like reversed on the denominator here. See, it's minus. Sine theta minus cos theta, alright? And then sine theta, it's difference of 2 squares. Equals sine theta plus cos theta equals negative b on a by 1. QED. The line y equals mx plus 2 root 21 just touches this random ass hyperbola. Find the values of m. I want to get a visualization for this. What one is it? What's the difference between these two last ones anyway? Oh, this one's like vertical. So okay, so it's this one then. Yeah. 16x squared. Alright, we are on 3b. 16x squared minus 9y squared equals 144. X squared over 9 would it be? Yeah, x squared over 9 minus y squared over 16 equals 1, yep. And that's what that's the form the calculator wants it in. So a equals 3, b equals 4, h and k is 0, and we draw. So it looks like that, right. And then mx equals there's probably... This is so sus. Is there even like an... Is there even like a... Cause... Zoom out. If I zoom out, like what is 2 root 21 even? Like... Thanks! Okay, it's 9.16. Okay. Like, it would be like... no. What this one? 9.16, that's like way high, right? Like... It's like way up here. 9.6 is like way up here. It's like way up here, so I don't see how any... Oh, if they say just touches, then... That's very sussy. NZQA is being highly sus right now. Okay. Because... Well, I mean, you just sub it in and see what happens, right? You just go 16x squared minus 9. This because it's like this is all the NZQA equation. Just sub it in. You go mx plus 2 root 21 squared equals 144, and delta. Oh, that comes later. 16x squared minus 9m squared x squared. I'd rather not expand it all at once. Plus 4 root 21 mx plus 84 squared equals 144. Okay, alright. The 16 minus 9m squared x squared plus, oh no, this is minus 34 root 21 mx plus 9 times 84. What's 9 times 84? That's 756. 756 equals 144. 16 minus 9m squared x squared, 36 root 21 mx plus 612 equals 0. I hope that's correct. 61144. Yeah, 612. Alright. This is highly sus though. This is so sus. Because like couldn't a line technically intersect the hyperbola in like 4 different places, but then you only get a quadratic? I just don't think too much about it. Okay. Actually no, you probably can't, cause like weird stuff happens. Since the line only just touches the hyperbola, then one value of x only, since m is not equal to infinity, then delta equals b squared minus 4ac equals 0. So 36 root 21 squared, that's going to be horrible. 27216 minus 4 times 16 minus 9m squared times 612 equals 0. 4 times 9 times 612. 22032m squared. Oh wait, this is not even that bad, right? Because it just reduces very nicely. Minus 4 times 16 times 612 equals negative 1. No, it's horrible. Why would NZQA do such a thing, bro? M squared equals... What? Nah, there's no... okay. No way NZQA does this like this. Like, what is this shit? Like, square root of, like, a number with... And this is, like, irrational? No way, bro, no way. No way NZQA is, like, down this bad, bro. Um, unless it is really like this, in which case it's a bit unfortunate, but ah, there's no squid there. Hold up. Yeah, no way it's gonna be this bad. What did I do wrong? Oh, this should be a minus. Yeah, okay. There we go. Well, hopefully that makes it better. Minus 900. Oh, 900 is a nice number. 900 times. Wait, that's a bit sus though. Times negative 900. Because now, oh no, it'll be fine. Because the coefficient of m squared will be negative, but then the coefficient of the constant term will be positive. No, the coefficient, yeah, the coefficient of m squared is negative. Yeah, definitely. Negative 4 times negative 9 times negative 900. That's negative 32400. Yeah. Well, it's already square of a perfect square. Sorry, it's already a perfect square, looking better. 27216 minus 4 times 16 times negative 900. That's 84816. I don't recognize that one, but I hope it's good. 32400. Oh yeah, already looking fairly rational. Screw it, that is... did I make a mistake? 84816. This is kind of sus. Like, okay, 3240 makes sense, right? Cause that's like an actually nice number. Right, like this one's also a fairly nice number, so because it's a... Yeah, you take the... Cause like square root of 3240 is like 180, right? So it's a nice number. Then this is just a not nice number though. It's highly sus. It's highly sus. Everything seems right though. Like, can I overlay? Yeah. No. Sketch. No. Oh, plot? What does this do? Does this plot? Does this plots points? Okay, that's a bit useless. Line. No. Line. If line? No, this is a line that you can put in yourself. This is not gonna really help you. Yeah, what's this line thing? It's like not doing anything. Okay. Okay. So I'll just gonna say, whoops. Just turn off the calculator by accident. Okay, hold on. It'll be back. Yeah, so just to let you guys know, like the calculator is actually like not a real calculator kind of thing, because like it only displays the screen, right? So I just went into GIMP, and I just like took a picture of like a calculator, right? Like a picture of a calculator off the internet, and I just made the inside part just transparent, and then I just made the outside part transparent as well. So like the screen capture only shows like the actual screen, which like looks horrible on the stream. So I just went and put this transparent bit around it, so it looks better. It's gonna write 589 over 50. I don't care anymore. Maybe I get 39. Maybe I get 38. Alright. M. Yes. Alright. Yep. Consider cubic function. The acute angle between the curve and the x-axis at points P and Q is equal to 45 degrees. What is this now? What is this now, bro? So like ax cubed minus bx, both positive real constants. Yeah, curve in the x-axis. Points P and Q is equal to 45 degrees. Okay, so so you see, right? So like the curve looks like this, right? That's like the basic thing. So it's like negative root b on a probably. Negative root b on a, and then this one is root b on a, and then this one should be 0. This one should be 0, alright, so like it's good. P and Q are symmetric about 0, so that means that we might be correct here. So if negative root 3 is equal to negative root b on a, then it's okay. I'll just write it out fully. Okay. If x equals ax cubed minus bx equals 0, ax squared minus b equals 0, x equals 0, or x equals plus or minus root b on a. The solution P and Q correspond to x equals plus or minus root b on a. Alright. This should be right. So hence root b on a is equal to root 3. B on a is equal to 3. Yes, b equals 3a. The acute angle, if the acute angle between the curve and the x-axis is 45 degrees, then f prime root 3 is equal to negative tan 45 degrees equal 1. Negative 1. Right, because like look at this, right? This is the curve, this is the angle, this is f prime. This is like a0 or something, this is f prime a. This is 1, like by definition of f prime. And so this is like arctan. So hence, but then f prime of x is equal to 3a x squared minus b. Hence 9a minus b equals negative 1. A minus 3b equals 0. No, the other way. 3a minus b equals 0. Alright, and then you use this very helpful equation solver. 2 variables. 9, negative 1, negative 1. 3, negative 1, 0. Negative a sixth and negative a half. Yeah, that was what I thought. So a equals. Wait, that makes no sense, bro. That makes no sense. Because like some dumb shit. X cubed minus x. Oh, it's the other way. It's the other way. Okay. Right. Okay. That makes more sense. Yoink the doink. Yoink. B on a. Negative root b on a x if x plus 1 and b equals 1 or 2 by solving simultaneously. Oh, and then this can be like, I don't know, y plus y negative y. There we go. And then the final thing is find f prime of 0. F prime of 0 is equal to negative b is equal to negative half. There we go. So let's just check this. 1 on 6 x cubed minus a half x. Trace and enable the derivative on, right? So you see this 1, no, it should be like root something or other. Yeah, somewhere around there. So like if you zoom in like a lot around here, zoom in, zoom in, zoom in, that doesn't look like it's viewing the initialize. Right. Zoom in, zoom in, zoom in, zoom in. Right, you can see it's basically 45 degrees. So yeah, seems legit. Alright, 3D. Oh, okay. This is the combi one. So yeah, 5 boys line up for photo. I assume the boys are distinct, like they're not all like, you know, undistinguishable clones of each other. That would be a bit sussy. Assuming there are they, the boys, are distinct, then there are 5 ways to put the first one, to choose the first in line, then 4 ways to choose the second, etc. So there are 5 factorial equals 120 combinations. Alright. 3D2. The girls always stand next to each other. Oh, I should scroll up, sorry. The girls always stand next to each other. Yeah, so you just like, I don't know, you just treating the girls, treating the girls as a single entity. There are 6 factorial ways to arrange all 6 entities. So there, but the girls can be swapped, which doubles the number of combinations. combinations. So there are 2 times 6 factorial equals 1440 ways. Alright, either the girls are together, or they are not, or they are not, hence the total of 2 and 3 should add to 0 factorial the number of ways to arrange 7 people. So the answer is 7 factorial minus 2 times 6 factorial equals, I don't know, what is this? 7 factorial minus 2 times 6 factorial is 3600. Cool. And I believe that's the end of question 3. Yep, okay. Alright, oh, people are putting their marks. Yeah, I hope you all did well, I guess. Hope you all did as well as you hoped to. And yeah, I hope you didn't make like silly mistakes and stuff. I can't speculate about cutoffs right now. Oh yeah, I did drop a negative. This is not an emulator. I've been looking for one as well, but this is actually a screen projector, right? So I have my calculator linked to the computer by USB. I can link you that, like the USB software later, but it's a Linux software, so actually I don't know whether it's Linux or Windows. It might run on Windows, but yeah, pretty sure it's like Linux. I'll link it to you later though. Thank you for the love, Big Boy Thickens. Yeah, I mean, fair enough, I guess. Thank you for your support. And then we'll go to question 4 now. Poggers. Question 4 only has 3 sub-questions. Seems nice. 4C ripped out of SMC, I see. Yeah, that's not very nice. Okay, young couple wants to buy a house. It's 76k in savings. It's currently insufficient for a mortgage deposit. After research, they invest all their capital in the Q-Saver fund and commit to annual deposits of 4,500. Government will contribute 500 to the fund each year as well. The fund has an anticipated average compound growth rate of 16% per year. What? Bruh, this is dry, bro. This is dry. Okay. Okay, this is not a good model, right? Because your like amount would end up like higher than it actually is. Why don't you just use, like, why don't you just say, I don't know, for the correct model is AN plus 1 equals 1.16 AN plus D. That's the correct model, right? But like, I mean, I don't know, if the QA wants to do whatever, then they can do whatever. So D is equal to 5,000 combined annual people plus government. So dA on dt. Wait, this is so dumb. Okay, so there's like no way to solve this other than integrating factors, right? dA on dt minus 0.16a equals 5,000 integrating factor e to the integral negative 0.16 dt is equal to e to negative 0.16 t. So d dt e negative 0.16 t times a is equal to e negative 0.16 t times 5,000. Integrate both sides. E negative 0.16 t times a is equal to 5,000 divided by 0.16 is 31 negative 31250. Wait, hold up. That's not right. That's not right. It's hella sus, bro. It's hella sus. This is hella sus, bro. So I'm just doing the integrating factor thing. Why is it negative? It should be positive, right? Yeah, bro, this is hella sus. I'm just gonna do it anyway, cause 0.16 t plus c1 a is equal to 31250 plus c1 e negative 0.16 t. Yeah, I definitely made a mistake somewhere here. 0.16 t. Because it shouldn't be like this way. The solution to this kind of DE should technically have a t term in it. Well, like, these are constant, right? Like, I don't understand what's going on here. The anticipated average compounding growth rate of 16% per year. A couple of years and blah blah blah. Forecast the success of that plan. Yeah, da da da. Maybe it is. Yeah, maybe it is correct. Yeah, yeah. So, it's really sus though. I don't know why it's negative. Actually, it could be negative. Yeah, yeah. Okay. A of 0 is negative 31250 plus C1 E0 equals 76,000. That means C1 equals 107,250. So A of 10 is negative 31250 plus C1 E negative 0.16 times 10 is equal to, wait no, positive, yep. Bruh, these guys, they got, yeah, nah, I don't know, man, they got sussed out, bro. They 499,962,963. So no, no, they're, so no, so no, they are $37 short to buy their house. Bit unfortunate, really, to buy their house. Bit unfortunate. Although yeah. Let me just check this because I'm slightly sussy of the solution. Like if I just differentiate it, right? A prime is equal to 250 e to the 16t. 17. What? 17 160 e to 0.16t 16a plus d is yeah 17 160 e. Oh yeah, yeah. So it is correct. It is correct. Yeah. Okay. So I don't know what I was thinking, but yeah, it seems correct. The function f of x satisfies differential equation. Why is it always differential equations? Okay. Okay. So what we want to do? Find explicit expression for the function. Alright. So this one for bi dy dx equals x minus 1 times y cubed. This one just 1 on y cubed dy equals x minus 1 dx. Integrate both sides. Negative y negative 2 times 1 on negative 2 equals x squared on 2 minus x plus c. So it's like 1 on negative 2y squared equals x squared on 2 minus x plus c. Bro, why though? Why? Given that f of 0 equals a, where a is a positive constant. Bruh. Oh wait, no, actually that's not too bad. Okay, it's fine, it's fine. So flip it over, negative 2y squared equals x squared on 2 minus x plus c to the power negative 1. Y squared is equal to, if you divide it by negative 2, right, then you multiply the inside by negative 2. So c to negative 1. Y is equal to the square root of that, basically. Y0 equals a, hence 1 on root c equals a, hence c equals 1 on a squared. So basically y is equal to negative x squared plus 2x plus 1 on a squared to the negative a half. Okay, seems reasonable. State the domain and range of the function in terms of a. Bro, what? Like, what do you want me to say? They want to complete the square or some shit. Like, I don't know, it's a bit sus because eventually y will go negative. No, eventually like negative x squared plus 2x plus 1 on a squared will go negative, and then can't really do much about that. But then y won't be real anymore. But then that's clearly not the case because like differential equation is well defined. It has a solution. It's IVP. These are fucked up again. What's wrong here? The integration's correct. Correct here, correct here. Yeah, that's what's wrong, to be honest. Like, there's no way this DE doesn't have a solution because it's like almost required to by like a theorem. It's kind of sussy. It's kind of sussy. Cause like alright, so we draw the y equals 0 is a null client. Okay, so like x equals t, right? Then dy dt equals t minus 1 y cubed, but then dx dt equals 1. So you draw like the phase portrait. Right, so this one you null clients, that's what do you null clients? So 1 t minus 1. So like let's say you start like down here, then y cubed is positive, but t minus 1 is negative. So you end up going down. They're going down. Like every like here is always horizontal, and then everything on the x-axis is also horizontal. Then here they're both positive, so it goes up. Right, and then here this one's negative, so it goes down. So it's like that. Cause it's like some sussy D, bro. Yeah, like there's no way the solution can be correct, right? Like, what the fuck's going on here? Like I would get like MATLAB out or like NumPy and like plot the vector field, but I don't think you're allowed to do that in the exam. Or maybe you are nowadays, because there is like Python for calculators, but yeah, it seems a bit too far. Like, you know, it goes down to the left and then up to the right. Okay, if I just straight plot, I don't know, 1 over root negative x squared plus 2x plus 1, then what do I get? And like, having a normal viewing window. So it just like goes up, basically. Kinda sussy. So what if it's like just 1,000? Oh, okay, it just doesn't go anywhere. Go about like something like 10. Right. Right, okay. That makes sense, I guess. But I still don't see why it goes like infinity. Because it is like a well-defined. Like, I don't see why there should be an asymptote there, right? Because or maybe it does have an asymptote. What does the theorem state? The theorem states that there's a unique solution to an IVP that's like linear. I forgot what the theorem states actually. Oh well. But like, it should be true, right? So I'm just gonna do it. I'm just gonna say the domain domain is when negative x squared plus 2x plus a 1 on a squared is bigger than 0, which means that, like, okay, so you draw the thingamajig here. It's like this, right? That means critical points are x equals, it's like almost negative, so the negative b so negative b is 2 plus or minus the square root of b squared minus 4ac on 2. 1 plus or minus square root 1 plus 1 on a squared. This seems right? This seems right? It does seem kind of right, yeah. So the domain, the domain is 1 minus that, less than x, less than 1 plus that, basically. Probably, I don't know. And then, okay, so we do question 3, part 3, 4b, part 3. The range. Oh, no, it still asks for the range. Okay. The range is, okay, so dy on dx less than 0, equals 0 at, x equals 1. And since dy dx this is 0 when x equals 0, dy dx less than 0 when x less than 1, and dy dx greater than 0 when x bigger than 1. This is a global minimum. The upper bound, there is no upper bound. The range y of 1, however, is -1 plus 2, -1 plus 2 plus 1 on a squared to -1/2, which is 1 plus 1 on a squared, 1 on that basically. So the range is, is 1 on square root of 1 plus 1 on a squared, infinity. Okay, it's probably correct. It seems correct based on, like, we calculated observations, but those are always a bit sus. So draw a sketch as a goes to positive infinity. That'll just be like 0, right? Wait, why do you even need a sketch as a goes to positive infinity? Oh, right. Cause it's, yeah, cause you can't technically have as a goes to positive infinity. Like it just looks like this, like x and y and asymptote. 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 X equals 0. Asymptote. X equals 2. Local min 1 1. Well, it's technically global min, I guess. Global min 1 1. Yep. Global min 1 1. Yep. Okay, so seems like all they would be asking for. Might as well say like undefined. Undefined. Fair enough. 4C3, yeah, this straight out of SMC a while back. Let me just check the 1 on 1 in squared plus n plus 1 squared. You know the dumb thing though, it's like NZQA says that you're allowed to use a calculator for the questions, right? And then if you use a calculator, you have to show the exact commands you used, right? So it's just like, I don't know, man. Option, calc, sum, square root, 1 plus 1 on n squared plus 1 on x plus 1 squared from x equals 1 to 20, 21. You just let that run for a while. This calculator is OC'd, so if you run it on your own calculator, it might take a bit longer, but yeah, basically you just get the answer, bro. And then like you can square it if you want, and then you just get, you know, the quote unquote exact value. This is like 2021 squared plus 2 times 2021 minus 1 probably, yeah. So okay, so but what we're meant to do, you're meant to like just rearrange it, right? You go n squared plus n plus 1 squared n plus 1 squared plus n squared plus n plus 1 squared through, and it's gonna be a telescoping sum, right? There's like no way around it. Has to be somehow. N squared n to the 4 plus 2n cubed plus n squared plus n squared plus n squared plus 2n plus 1. All on n plus 1 squared. And then this is equal to n to the 4 plus 2n cubed plus 3n squared plus 2n plus 1. Highly sus, bro. This is highly sus. This is like sussier than I don't know. I can't. Well, like one way to factorize something is to look at its roots. So bro, it has no roots. That's dry. It's actually dry. What do you do if it has no roots? You can't factorize it, right? You just can't factorize it. That is a bit unfortunate. But like remember you're supposed to end up with 2021 squared plus 2021 minus 1. That's what you're supposed to end up with as your final answer, right? So it's like, I don't know, man. Wait, there's also like, what is it? 2020, 2 squared minus 2. Yeah. So you're supposed to end up with like n plus 2 squared minus 2 as your final answer. It's highly sussy, bro. It's highly sussy. And then you know that it has to telescope somehow. Because that's just how all these problems are. They telescope somehow. N to the 4 plus 2n cubed plus 3n squared plus 2n plus 1. Bro, this is such a sussy problem. Now let me get a drink. Okay, okay. I'm back now. So it's just like, mm, so that somehow is to end up as like n plus 2 squared minus n plus 1 squared or something. Probably. Because like if you go n plus 2 squared. Oh no, it's the square root of this, isn't it? Whoops. It ends up as like the square root of this. See, adding square roots is always kind of sus. So like T1 is equal to root 5 on 2, I believe. No. T1 is equal to 1 plus 1 plus 9 on 4. No, 1 plus 1 on 4. Which is equal to 9 on 4. Which is equal to 3 on 2. T2 is 1 plus 1 plus 1 plus 1 on 4 plus 1 on 9. Which is equal to 1 on 9, which is 49 on 36. 49 on 36 is 7 on 6. See, yeah, it has to be something like this, right? Like, it's something squared. It's always something squared, yeah. Or maybe something like positive definite squared as well. Maybe try like n squared plus n, because like this is 7, this is 3, right? So it's like always one more than the bottom. Let's try n squared plus n plus 1 squared. Oh yeah, this works out. 2n cubed plus 3n squared plus 2n plus 1, yeah. Yeah, okay, that makes sense. N plus 1 squared, which equals to... Well, but then why would it be the square root of that though? That's so sus. So sussy. Oh well. Yeah, so this is equal to n squared plus n plus 1 on n squared plus n. Good shit. No, not really. Yeah, it is, right? 2 squared plus 2, 2 squared plus 2 plus 1, yep. Which is then equal to 1 plus 1 on n squared plus n. Yep. And that is then equal to... Alright, it's equal to n plus 1. Oh yeah, I think the sum actually wasn't correct. Let me check with like something smaller, cause sometimes it does make mistakes. X from 1 to 100, something like that. You still can't. You have to d it. Times 99. Yeah, close enough. Answer squared Yeah. Yeah, it's a bit sussy. It's a bit sussy. Okay. Well, anyway, like you get this. Partial fractions will give you this. Right, and then you're basically done, right? Is that correct? The one on n plus one on n plus one. Wait, hang on. Odds times 101, right? Yeah, okay, okay. Yeah, that makes more sense. So it's negative the next one, positive the first one, I think. 3 on 2 is 1 plus. Yeah, oh yeah, okay. So it's positive this one minus this one. I mean, you could do it properly, but yeah. Hence, now we're like almost done, right? Hence, sum from n equals 1 to 2021 of Tn is equal to 1 plus 1 on 1 minus 1 on 2 plus 1 plus 1 on 2 minus 1 on 3 dot 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 1 plus 1 on 2021 minus 1 on 2022, which is equal to 2021 plus 1 minus 1 on 2022, which is equal to like 2022 minus 1 on 2022. Oh, come on. 2022 squared minus 1. That thing. 408.8483 on 2022. Should leave is the correct answer. I can test it. 1 plus 1 on x squared plus 1 on x plus 1 squared from x is 1 to 2021 times 2022. Alright, let's leave that running for a while. Oh, you could separate the variable, probably. My stream delay is not really bad. Oh, it's like 20-30 seconds, so I don't know if you consider that bad then, yeah. But I just read all the questions, like, I just read the chat after I finish every question, so I don't get like distracted or like answers and stuff. Kushla, I am not using a calculator emulator. I'm using P7 screen with the FX9750G2. Like, okay, so I'll show you this, right? So this is just like an image. This is just like an image with a transparent inside and transparent outside. So I can just move that around. I just got it so that it looks better. And then this is the inside part is actually the calculator, and that's just a USB projection. So like I'll send you the P7 screen. P7 screen P7 screen FX calculator. Yeah, okay, I don't think it's available for it's not available for Windows, unfortunately, but this is what I use. So it just lets you basically just lets you so the main part of it is P7. P7 lets you transfer files from the calculator to your from the phone, not from the computer to the calculator and vice versa. And then P7 screen is the one that allows you to project from the calculator onto the actual screen. I think the actual calculator is a FX9750 G2. But mine's in dark blue instead of purple. But the purple one on, like, the purple image on the web was like higher quality, so I just used that one. Like the dark blue one was like blurry as. I couldn't be bothered taking like my own picture, so yeah. That's that, and then yeah, FX1950 G2 is the actual calculator being used. So yeah, have a play with it. I think if you're on Windows and you actually have the calculator disk that came with the calculator, you might be able to get it working with FA124, but I'm not so sure about that. Yeah, so this is what I use. Nah, all good, bro. Yeah, Ning's very helpful. Yeah, I'm sure he'll help you with it. Maybe. Alright, so question 5. Consider the points A12 and B34 on the Cartesian plane. BC is the line perpendicular to the line AB. Alright, 5A. So, okay, so we have the points AB, X, Y. So A is like here, and B is like here. A12, B34. BC is equal to 4AB, then find the possible coordinates of C. Oh, I see how it is. I see how it is. So C is like either here or like here, basically. So this is just 2 root 2 basically. Because this DAB is equal to square root of 3 minus 1 squared minus 4 minus 2 squared. 4 plus 4. Oh, this should be plus. So it's like 2 root 2. 2 root 2. So DBC is 8 root 2, and MBC is negative MAB. 1 on MAB, which is negative 1 on 1, with negative 1. So C equals, the vector C is equal to the vector B plus or minus the vector 8, negative 8. And hence C equals 11, negative 4, or negative 5, 4, probably. Z equals IY where Z equals X plus IY where X and Y are real. Find all complex solutions to this equation. Z equal Z plus 1 on conj Z equals Z prime plus 1 on Z. It's a bit sus. X plus IY plus 1 on X minus IY equals X minus IY plus 1 on X plus IY. Alright, fair enough. You can cancel the x's. IY plus X plus IY on X squared plus Y squared is equal to negative. Let's go 2IY. 2IY X minus IY on X squared plus Y squared. 2IY X squared plus Y squared plus X plus IY equals X minus IY. 2IY X squared plus Y squared plus 2IY equals 0. 2IY X squared plus Y squared plus 1 equals 0. So either X squared plus Y squared equals negative 1, not possible, or Y equals 0. Does that seem reasonable? Cause like, okay, so if you like consider, like a thing, right? So if Z is here, right? Z is here, then You know, this is like a dumb, this is a troll question, bro. This is a troll question. This is a troll question. This is a troll question, bro. Look at it. Z plus 1 over Z prime, right? Bar that is equal to Z bar plus 1 over Z. So like, if A equals Z plus 1 over Z bar, then A bar equals A, so A is real. A is real. So Z plus 1 Z bar is real. Right? That's weird. Bit sus. Highly sus. Z plus like okay, so if this is Z, right? This is Z, then like this is 1 over Z bar. So like it's like there's no way it can be real if Z is real. Yeah, okay, so find all complex solutions. So the complex solutions. So the solutions are Z in R. Like I'm assuming when they say complex solutions, they mean like in the set C, right? Like they wouldn't be like they wouldn't do us like that, right? They wouldn't be like, oh, actually there are no complex solutions because they're all real solutions. I assume they just mean like when they say complex, I assume they just mean like in the set C. That makes the most sense to me, right? So yeah, that's what I'm assuming. Oh, you should put this like it's like if there's like theater, there's like theater as well. 5C1. Consider all complex number Z that satisfy the equation. Yada da da da. It's like this is an ellipse, right? Because distance to 2 points adds up to a fixed number. So like, okay. So you have here x real and imaginary. 2 plus 4i, they would be like around here, right? If like this is a square and this is another square, yeah. 2 plus 4i, and then this would be 0. Draw a line like roughly through there. This would be 3 plus 6i, and then this is like the ellipse semi-major axis. This is something like this is an ellipse. This is an ellipse because the semi-major, the distance from Z to the total distance, each of 2 points, is a constant, which is 4. Find the maximum value of Z bar. Oh, sorry, I should scroll up. Oh, I actually can't scroll up. Hold on. Let's go yoink and yoink. Let's see. Yoink. No, I need to scroll up a bit more. Bruh. No, that's not what I want to do. I want to do this. Yep, and I scroll down a bit. Alright, alright. So yeah, so this is the ellipse. And if we want to find the maximum value of z bar, then that would just be how would that be? That would just be in because like you know the semi-major ellipse, the semi-major axis, the semi-major axis, the semi-major axis. Actually, this is the major axis, right? I think the major axis of the ellipse is okay. The origin lies on the extension of the major axis of the ellipse. Hence, the point that maximizes z, that maximizes z. Whoops. The point that maximizes the absolute value of z will be the point on the major axis furthest from the origin. 2.5 plus 5i. Here, z mod z is equal to mod 2.5 plus 5i plus 2, which is equal to the square root of 2.5 squared plus 5 squared plus 2, which is that 4 plus 5 root 5 on 2. Whoops. And there's the answer. I don't really know how to check it with the calculator, but yeah, you can. It's probably right. Gotta expand this and maybe expand a bit more. How's that looking? Yeah, she'll be right. Okay. Oh no! What is this? ABC is an isosceles triangle with ABC equals ACB equals A. Okay. The vertices yada yada da. Okay, I see how it is. Without. Alright. Without loss of generality. 5D. Without loss of generality. Assume z1 equals 0. Then this is okay because subtracting a constant, here's z1, does not change the angles. Here's z1 from z1, z2, z3, does not change the angles or the values of z2 minus z1 and z1 minus z3 and z2 minus z3. It represents a translation. Alright, so then without loss of generality, also assume z2 equals z2 equals 1. Uh, uh, so then sufficient to prove z2 times negative z3 equals a half z2 minus z3 sec alpha squared. Also without loss of generality, assume z2 equals 1. This is fine because dividing z1, now 0, z2 and z3 by the same number does not affect z2 and z3, does not affect the angles, and since LHS and RHS are both degree 2 in z2 and z3, because say rz2 times negative rz3 equals r squared, z2 times negative z3, a half rz2 minus rz3 sec alpha squared equals r squared, a half z2 minus z3 sec alpha. Like you can see that, like, because the r squareds come out, and then this part is the same as this part is the same as this part. Like, it doesn't matter if you multiply it by, like, if you multiply everything by r, so you can just say that hence we'll log z2 equals 1. You can say that like z2 is 1, and then you get like this diagram, because like the angles haven't changed basically. This is A, B, and this is C. Right. B1 and C is a C3. This is 180 minus 2 alpha. Since triangle ABC is isosceles, then Z3 equals 1, and hence Z3 equals this 180 minus 2 alpha is equal to negative cos 2 alpha plus I sine 2 alpha. Now we just plug it in and it should work. Now LHS equals negative Z2 Z3, which equals negative Z3 is negative the cos 2 alpha minus I sine 2 alpha RHS equals a half 1 minus Z3 sec alpha squared. It's like a quarter sec alpha minus cos 2 alpha minus I sine 2 alpha. No, minus cos 2 alpha sec 2 alpha minus I sine 2 alpha squared. It's supposed to be the same as the left hand side, but I don't quite buy it at this time. Oh, there needs to be a sec alpha, yeah. Sec alpha squared. Sec the quarter. Sec alpha minus cos squared alpha minus sine squared alpha. Sec alpha minus 2I cos alpha sine alpha sec alpha squared is equal to a quarter sec alpha minus cos alpha minus sine alpha tan alpha. Yeah, no, this is better the other way, I reckon. Minus 2I sine alpha squared. I can kind of see where this is going now. Kind of. It's not looking good, but a quarter sec alpha minus cos alpha minus sine alpha tan alpha. No, this has to be plus, yeah. Squared plus. Well, this is minus, so it's like actually minus. Wait, what? This is so weird. Nah, I'm sure it'll work out. No, so like you go minus 2 sine alpha squared, right? Cause yeah, and then minus 2I sine alpha sec alpha minus cos alpha plus sine alpha tan alpha. I'm not confident this goes back to 2 alpha, honestly, cause well, it should. Maybe it does. It's very sussy. This is very sussy. Z3 should just be negative cos 2 alpha plus I sine 2 alpha. Yeah, so I've substituted in correctly, so everything should just work out. Oh, you hope so. This is a bit sussy. Okay, yeah. What if like I got a better idea. Like you see this, right? This is by sine rule. By sine rule. By sine rule BC over sine 2 alpha is equal to 1 over sine alpha. So actually BC is equal to sine 2 alpha over sine alpha, which is equal to 2 cos alpha. So B minus C, no, so C minus B, so Z3 minus 1, C minus B, which is Z3 minus 1, now you equal 2 cos alpha, cis 180 minus alpha, 2 cos alpha, cos, negative cos alpha, minus I sine alpha. Maybe that's the same thing that I got down below. Plus I sine. That's basically the same thing as I got down here. No, not really. I multiplied by sec alpha too early? Maybe? Oh, no, I get it, because instead of doing this, right, instead of doing this substitution, you go 2 cos squared alpha minus 1. Then you go get rid of this and this. No, wait, do you do that or do you do 1 plus? No, you do 1 plus, 2 sine squared alpha. So you got 1 minus 1 plus 2 sine squared alpha minus sine 2 alpha. Oh well, that's like sine alpha, cos alpha. And these two should cancel, and then yeah. Okay. But and then we call this star. By star RHS equals a quarter 6 squared theta 6 squared alpha, sorry. Quarter 6 squared alpha. So this is C minus B, right? But then you want B minus C. So in the negative of that. So you want 2 cos squared alpha. 2 cos squared alpha minus 2 cos alpha sine alpha? That also doesn't seem right though. That's highly sus. Highly sus. Okay, whatever. I don't care anymore. I'm just gonna do it and then see how it goes. There should be an I here though. I'm definitely missing that. I and then squared and then 6 squared alpha, because you can cancel the 1 on 4. Cos to the 4 alpha. cos squared alpha minus sine squared alpha. That's 2i sine squared alpha. Cos 2 alpha, that's like the identity. Yo, what? Oh, right, because this is actually, this you get cos multiply, yeah, so this should be cos cubed. Right, because this term comes from multiplying these two terms. And then so that means at the end you don't actually get sine squared, you get sine alpha cos alpha, which is conveniently 2 I sine 2 alpha, which is the left hand side. And then so we're done. Because like this expression cos 2 alpha minus I sine 2 alpha is the same as this expression. So we're done basically. We finished 14 minutes? No, 24 minutes. We finished 24 minutes before the time is up, so I would say that's pretty good. Yeah, last year we had to go over time, which is a bit unfortunate, but yeah, this year we managed to finish on time, and I didn't need any help, so that's good. I think this year was probably a bit easier than last year, judging both by my personal experience with the questions and also hearing what other people have had to say. But yeah, I hope you all did well today. And good luck for your next scholarship exams. Speedy memes. How do I get roots to be in exact mode? I downloaded a different OS on my calculator. Hang on. Fix. I'll find you the video. I'll find you the video. It's like no, it's not this one. Let's see. I think the one I used might not be online anymore. Oh no, it still is. It still is. Alright, yeah, here's the link, bro. Yeah, so you followed the instructions in that video. And it should just work out for you. I have had one person report that they know someone who has bricked their calculator doing this, but I have done it, and I've done it for some friends, and some other people I know have said it's fine. So your mileage may vary. Do it at your own risk. You know, like don't blame me if anything goes wrong. But yeah, I think definitely a worthwhile upgrade though, if it works for you. Yeah. So yeah, if there's nothing else, then I'll just stop the stream. Good night, everybody, I guess. And see you next year.